This is Computer Science 47, Computer Organization Study, Lecture 12. We'll review procedure implementation at low level, at assembly level in this lecture. We have we'll have couple of subtopics, like we'll review what a procedure call or function call means, and then we'll look at how the low level function or procedure call is implemented, and then we'll talk something about call a runtime environment and also the storage of the runtime environment during running of the procedure call. So let's first review what is a procedure call or function call, right? There are two notion in the computer science programming, high level programming area, like function call, which essentially encapsulate a common code and return some value from that specific function. And there is another notion called procedure, also in terms of computer science high level programming, which sometimes we also call methods, right? And essentially these things kind of abstract a couple of steps together, common steps to achieve certain goal. The distinction between function and procedure is very blurry. Like they are even method, like in terms of object oriented programming we call it a method. So they are all like interchangeably used time to time. But one thing for sure, function, whenever we refer to a function, it needs to return a value from it, right? In terms of procedure, it need not return any value from that common set of code, right? And but all of them takes like list of arguments and process it, argument value, etc. So in C++, that language supports both function and procedure implementation. Procedure implementation is done in a way that its return value is called a void. I'm not sure if Java supports that or not, void return, but well, that's subject to implementations detail in the high level language. But at least at the C++ level, we can kind of safely distinguish between a function and procedure, as a function returns a valid data. It can return an object or very fundamental data structure or data types, and procedure doesn't return anything. Okay, it's a void. We call it a void return. There is a type called void. Void means it's none. Okay. Now, so with that respect, let's take a look on this high level procedure call, right? Let's say, or function call in this case. Basically, it is trying to ask you a number, positive number, and then it prints a factorial of that number by calling a function called a fact. So at this lecture, we'll use the term procedure interchangeably with function and method alike. Okay, so let's see what is this factorial look like. One such implementation of factorial we can make as this, right? A factorial, let's say I want to have an integer n, factorial of n, and if n is less than 1, then return 1. So we know the 0 factorial is 1 and 1 factorial is 1. So less than 1, we return 1. That is the base case for this function. Otherwise, we return n multiplied by factorial of n minus 1. So this is directly coming from your factorial definition. So factorial definition, factorial n definition is n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 in such a way that till you multiply it with 1, right? Till 1 to n. So we use that definition and just call the factorial function itself, like this being this means this is being a recursive function implementation, right? So a function calling itself to implement its body. So it becomes a recursive function call. And we'll focus in this lecture on this specific routine. We'll give example around this function, recursive function called fact. So how it works, from the main, let's say you type a number a, some number 10, 11, 12, etc., some number a. So it assigns, so that means it passes in the first call from the main, it calls the factorial with the value a, right? And then it goes into the body and check if that n is less than 1 or not. If it is less than 1, it returns 1. Otherwise, it first call itself with one less value, like n equal to n minus 1, and call itself, right? So then if it is still not the base case, it basically do n minus 2 effectively. So whatever value it is getting at that point, it will call itself by 1, decreasing that value by 1. And once it hits the base case, right, then it comes back. It comes back from the base case call to its caller, which is by itself, right? So then what it does is basically, ultimately it basically your returns back as a factorial of n minus 1. Then it returns back to the caller, ultimately that value being multiplied with n and returned back to the main as a value of the factorial a, right? So that's how your recursive call works, at least by conception. We'll see at the low level how that works in a minute. So function is, you can think it's like a black magic to the caller. So the caller does not know what it does inside. Like there can be various type of implementation. You can have a non-recursive implementation for the factorial program itself, right? So as a caller, like no one like bother about how internally that specific function has been implemented. It is almost like a black magic. So I pass you whatever value you required to compute something from me. Based on those values, you compute and give me back the result. So I really don't care what you do inside. That's what meant by the black magic. So a couple of basic things here we are doing, like knowing or unknowingly we are doing. One is that we pass the argument and we need to know how we'll be doing at the low level. Like pass the argument at the high level, we all know, as we have done programming in the high level language. So low level, we need to know how to pass an argument. Then how to transfer the control to the function, right? In the high level language, we just type in that function name within round braces. We type in the arguments, whatever number of arguments it need, and we are done. We know that at that point, that function will be called, that code will be called and being executed with the given argument. At the low level, we still need to know how do we transfer the control to the function. Then we also need to know how do we need to return the result, and then we need to know how to return to the caller. In the high level, we kind of assume after the function call is done, we just get back to the next instruction that high level program has, right? So this is kind of given to us at the high level program. In the low level, however, we need to actually really do this ourselves. Okay, there is no construct in the low level assembly programming that you can type as a function and call it somewhat function as a high level. We'll see a function itself is a body series of assembly level instruction. Its name being is a label. Okay, the function name being a label itself, and we'll see how the return mechanism works and stuff like that. But that is what the how part we need to know. perform the task is a black magic. That is the body of the function that you need to write yourself when you're implementing a function, but when you are calling it, you basically don't care. Okay. So one another expectation is that the caller's runtime environment is not altered. So we'll focus in one section that what we mean by a runtime environment and how we make sure that runtime environment is not altered. So at the high level programming, conceptually, means that let's say you are calling a function from one at a point of your code, right? And you had certain variables stored and etc etc. So your expectation is that when you come back from that function, your variable is not altered, at least the variables which are not passed to the function as a reference, right? Or those, at least those variables, you assume that value won't be changed after the function call is done. So again, at the high level, this is kind of given, right? You don't even think of, when you write a high level program, you don't even think of that this function is going to change my variable that ever from my caller side, right? From where I am calling till that whatever variable I have stored, my function is not going to alter those values. This is kind of already given, and we are so kind of accustomed with that idea, we don't even think, okay, this is a big deal. But at the assembly level, this is a big deal. Okay, so you need to have a very specific focus on this topic, that you don't alter runtime environment. We'll see in this lecture later.